Like in this class, we will be saying solution of a homogeneous system of equations. In the previous class, we have seen non-homogeneous system, right? So, we will recall the previous session that this a1x1 plus a2x2, sorry, a1x plus a2y a1x plus b1y plus c1, anything, any measurement, any constant you can take, equals d1, and a2x plus b2y c2z is equal to d2, a3x plus b3y c3z is equal to d2. Okay, this like we have seen in the previous one. So in this d1, d2, d3, all the three become 0 means we say it is homogeneous system. That's all. So instead of d1, d2, d3, we'll be having all zeros. Okay. So we'll recall this previous method once again. We'll use this augmented matrix. Remember, AD, like this augmented matrix will write based on the rank we'll decide. Okay. Like how we'll decide, remember, if the rank of A should be equal to rank of AD, then we say it is consistent. If that is equal to the number of unknowns, then it is unique solution. If it is less than the number of unknowns, then it is infinitely many solutions. If they are not at all equal, then it is no solution, like we have seen. Whereas in the homogeneous system, there is always only one solution. We call it as a trivial solution. You see, sum of three things becomes 0. It happens only when all the three becomes 0 only. Okay. So, x is equal to, y is equal to, z is equal to 0 is a trivial solution. Trivial solution means you don't have to check. Like sun rises in the east is trivial, right? Like that, 0 is a solution for this. Okay. So, here it's based on, like as designing a solution, we say the non-homogeneous system, the homogeneous system is always consistent with the solution, but either it may have a trivial solution or it may have an infinitely many solution. So when it will have trivial solution, it will have infinitely many solutions. If delta is equal to 0, delta means the determinant. That means determinant of A equals 0, then it is trivial solution. If this del is not equal to 0, then it will be having infinitely many solutions. Okay, del is 0 means trivial solution, del is not equal to 0 means infinitely many solutions. Okay, that is it. Now based on this, we'll solve one question. Sorry, I was wrong. See, del is equal to 0 only, we have infinitely many solution. Del is not equal to 0 only, we have the trivial solution. Okay. So if del is equal to 0, homogeneous system has infinitely many solutions. If del is not equal to 0, then the homogeneous system has unique solution. That unique solution is the trivial solution. Okay. And the homogeneous system of equations always have at least one solution, as we already discussed, deciding the trivial solution already. Okay, at least one. It can be more than one also, but no solution is not possible. Okay. And the system of equations Ax is equal to 0 has two kind of things. Like we'll write this as a system of equations Ax is equal to 0 matrix, right? Ax is equal to 0, right? Here, this rank of A is like this 3, that means the number of variables. Then it is having unique solution. Okay, and the rank of A is less than 3. this rank of A is less than 3, then it is infinitely many solutions. Now compare it with the previous one. Previous one, what we have seen? Remember? Same thing. There we compared rank of A, rank of A with the rank of AD, the augmented matrix. Here it only depends on the rank of A. Okay. Alright. Okay. Then, based on this, we'll solve one question. Question number 1. Solve 3x plus 2y plus 7 is it? X minus 3y minus 2z is equal to 0 and 5x plus 9y. Okay. Now in this question, it is given that solve these three equations. That's all. That one given. Okay. Now, were they mentioned any homogeneous, non-homogeneous system, anything? Same like what we are question is on, like previous one. But we have to identify that after observing these things in all 0, this is a homogeneous system. Suppose we have one variable here. Here minus 5 is equal to 0, like it is there. We should not decide by seeing all these 3 zeros, it is a homogeneous system. Just look for a constant term. If any constant term is there, that constant term should be transposed to the other side. Okay. So as this is having entire thing equal to 0, the rank is entirely depends on this. We can calculate determinant. See, we can calculate determinant. If determinant equal to 0, we say infinitely many solutions, but we can't find the solution. Like that here also, based on the determinant. Based on the determinant, we can simply say whether it is having infinitely many solution or trivial solution. That's all. But to get the solutions, we use this method. We will find rank of A. Okay. So for that, we should write the matrix A. The matrix A is 3, 2, 7, 4 minus 3 minus 2, 5, 9, 23. Okay. Now we will write an equivalent matrix. Or there are several methods to calculate rank. Remember, we will calculate the determinant and then submatrix will take, for that submatrix will calculate determinant. Difficult. Then echelon form. What is echelon form? Try to get 1 here. After that, here 1 0, here 2 zeros. That is it. Now to get 1 here, what we can write? I am going to take R1. In R1, I will write R2 minus R1. Okay. R2 is 4 minus 3 minus 2. R1 is 3, 2, 7. Now we will subtract 4 minus 3, 1, minus 3 minus 2, minus 5, this is minus 9. Now the remaining things, 4 minus 3 minus 2, 5, 9, 23. Okay. Now using that one, we will make that place 4 as 0. How we can make that 4 as 0? Like we will take R2, that R2 minus 4 R1. Okay. In R2 we have 4 minus 3 minus 2. 4 minus 3 minus 2. And 4 R1. This R1 should be multiplied with 4. So that is 4 minus 20 minus 36. We should subtract minus plus, this is plus. Now adding this 0, this is 17 and this is 34. So we will get this is 1 minus 5 minus 9, 0, 17, 34. Now this also can be made as 0 by using another one. So I'm going to write in R3, R3 minus 5R1. R3 we have 5, 9, 23. 5, 9, 23. 5R1. 5R1 is 5. 5 5s are 25. This is minus 45. Then minus plus plus. This will become 0. We get 34 and 68. So 0, 34, 68. Okay. Now try to get 0, man. Displace 0. How we can get? We'll take R3. R3 minus 2R2. That's 17 into 2 is 34, right? Easy. So R3 is 0, 34, 68. 2 times R2. 2 times R2, 0, 34, 68. You should subtract. We will get 0, 0, 0. Then we get 1 minus 5 minus 9. 0, 17, 34, 0, 0, 0. So we get rank of A is equal to 2. Okay. If the rank of A is equal to the number of unknowns, we say it is what? What solutions? Unique solution, and it is trivial solution. See, unique solution or trivial solution. Rank of A is equal to 3. Number of unknowns. Okay. This is unique solution. That's a trivial solution. Okay. And here it is less than 3 we got. Then what solution will have? Infinitely many solutions. Okay. So to get the infinitely many solutions, we will write this again in the equation form. I hope you know from the previous classes. Again we will write this in the equation form. Remember the first equation, x minus 5y minus 9z is equal to 0. Here 17y plus 34z is equal to 0. Then how to find the infinitely many solutions, you remember? Yes. Any variable you can choose. I am going to substitute z is equal to k. Then this 17y plus 34k is equal to 0. Then y is equal to minus 34k by 17. Okay. Then we get minus 2k. And the x value we should get. So that is x minus 5 into minus 2k minus 9 into k is equal to 0. X minus 10k minus 9k is equal to 0. Not minus, x plus 10k. Then x plus k is equal to 0. We get x is equal to minus k. And y is minus 2k, z is equal to k. This is the solution that we look for. Okay. Any doubts on this? For each value of k, we have different different solutions. Okay. Next, the method to solve the non-homogeneous system. Apart from this, there are several ways we can use to solve the non-homogeneous system. Where is this? Shall I erase this?